Our new unit is rational functions. Rational functions are basically your fractions. You'll learn how to multiply and divide, which is what we're going to do today, add and subtract, which is what we're going to do tomorrow, and then solve equations and graph. Now, really all they are in general are just fractions with x's going on in them, because it's one function divided by another. So here you have a quadratic divided by a constant. Here you have a linear divided by a line divided by a line. And just learning what to do when that happens is the whole point to this unit. Okay, so multiplying and dividing rational expressions. If the problem you're given is division, and we're not going to get to that till right here, you're going to flip the second fraction and multiply. So that's what you do when you're dividing fractions. If you have to divide, what you really do is just flip this and multiply by the reciprocal. Alright, next you'll factor everything, then you'll cancel what you can, and then lastly you'll have to state the excluded values. Now this is not difficult, but it's a little weird at first. Alright, so number one, it says 4x squared divided by 5 times 10 divided by 3x to the fourth. Now most of you, coming from Algebra 1, would say that that is equal to, and I'm going to leave some room because I'm going to come back and talk about that. That's equal to, well, 4 times 10 is 40. You get x squared. 5 times 3 is 15. And you have x to the fourth. And then a lot of you would just stick 40 divided by 15 in your calculator. And let's say they both are reduced by 5, so that's 8 over 3. And then 2 minus 4 is negative 2, so you would have x squared in your denominator. And that is your answer without doing that. Now, in order to understand what we're going to be doing, because it says factor everything. Well, what's really going on in these bigger problems is you're going to break things down. Now, if you broke this down by like number tree, that's 2 times 2, xx, because 4 is 2 times 2, x squared is xx, 10 is 2 times 5, in the bottom we have a 5, we have a 3, and a 1, 2, 3, 4 x's. Now what's going on really is that you're canceling the things that you have in common. So in this one what happened is it had the 5 here that could cancel with the 5 here, and then one of the x's canceled, and the other x canceled, and so you were left with 2 times 2 times 2, which is 8, over 3x squared. Alright, the excluded values. The excluded value is what would make the denominator equal to 0. Because you can't divide by 0, and you know that. So on this one, if x were 0 here, then the whole denominator would be 0, so for this one, x can't equal 0. Example 2. Your first step is if it's division, flip. We're not doing division. Step 2, factor everything. So what I'm going to do first is factor everything. And now this problem will become a lot more like this step here that a lot of you just kind of skip over so far. X minus 5 stays x minus 5. X minus 4 stays x minus 4. Now here we have a GCF. Now a lot of you like to think the GCFs aren't important, but for this they really are, because they allow you, if you take them out, they allow for things to cancel. And then you have x plus 8. So in this we're looking, what do we have in common? What can we cancel out? And you can only cancel the top with the bottom, but they don't have to be right above each other. So right here, the x minus 4 cancels with the x minus 4, and you're left with x minus 5 over 10 times x plus 8. Our excluded values are a little more complicated. So your excluded value is any value that can make the denominator equal to 0. So where I look for my excluded values is after I've factored, but before I've canceled. So when I look here, I'm looking in my denominator to see what would have made it equal to 0. Well, the simplest way to do that is to set my denominator equal to 0. And right there, what would that be? Well, if x were 4, 4 minus 4 is 0, 0 times 10 is 0. So if x is 4, then I'm dividing by 0. And you know you can't do that. So x can't equal 4. Right here, you said x plus 8 equal to 0. You also have to worry about that one. So x also could not have equaled negative 8, because these are the things you don't want it to equal. It cannot equal that, or else something that's undefined is going on. So your final answer to this whole problem is right over here in purple. It's x minus 5 divided by 10 times x plus 8, where x could never have equaled 4 or negative 8. Okay, third problem. This is when it's finally division. Woohoo! Now we finally get to do some flipping. Alright, so because it's division, I'm going to go ahead and rewrite this immediately, flipping this fraction. So the first fraction stays the same. And the second fraction gets flipped. Now this problem is just like the last one. We have multiplication going on, and we need to worry about factoring everything. So bringing this around over here, in my numerator I'm going to factor out a 5. In my denominator I'm also going to factor out a 5. And over there, x minus 7 is as simple as it can get, and 1 is as simple as it can get. So we're looking for what can cancel. Well, we have this x minus 7 in common, and the 5s also out front can cancel. Your GCFs also can cancel each other out. Okay, or even reduce. They don't even have to cancel out completely. So what this leaves us with is just x plus 5. We still need to worry about our excluded values, though. Now right here, we have that x minus 7. Let's see, let's get the green around that again so we can look at where we're looking for excluded values. So we're looking anywhere in here. So when x minus 7 is equal to 0, that means x is 7, so x cannot equal 7. And with division, you have to look at both the numerator and denominator here, but since this one's the same as that, we're done, and 1's just a number, we don't have to worry about x anything there, so this is it, and we're done.